In this video, we're going to go over the fundamental theorem of calculus, part 1 and part 2, and we're going to work on some examples. So let's start with part 1. Let's say that g of x is defined as the antiderivative of a to x of f of t dt. So basically, g of x represents a function that tells you the area under the curve between 2 points, in this case between a and x. So g of x is a function of the area starting from a with respect to x. Now f is a continuous function on the interval a to b. And also, g of x will be a continuous function on the closed interval a to b, but it's differentiable on the open interval a to b. And the conclusion of the fundamental theorem of calculus, part 1, is that the derivative of g, or g prime of x, is equal to f of x. So integration and differentiation are inverse processes of each other. G is the antiderivative of f. So therefore, the derivative of g will equal f. But now, how do we apply this information in a problem? So let's say if we want to find the derivative of the integral of 0 to x square root 1 plus 3t dt. So we can see that this function is f of t. And we're differentiating g of x. So we're looking for g prime of x. This entire function is called g of x. The final answer is equal to the square root of 1 plus 3x. Now let's make sense of it. We know that g of x is the antiderivative, or the integral of 0 to x 1 plus, or f of t dt, according to the fundamental theorem of calculus. And g prime of x is equal to f of x. Now, if f of t is the square root of 1 plus 3t, then it makes sense that f of x is simply square root 1 plus 3x. If we differentiate both sides of this term with respect to x, on the left this is going to be g prime of x. On the right, this is going to be equal to f of x, which is square root 1 plus 3x. Let's try another example. Let's say that g of x is equal to the antiderivative of 4 to x ln t dt. And let's find g prime of x. So in order to find g prime of x, we need to take the derivative of both sides of the function with respect to x. The derivative of g of x is g prime of x. And according to the fundamental theorem of calculus, the derivative of this function, the derivative of the integral of ln t dt, is simply going to be ln x. Now remember, f of t is what we see here. It's, in this case, ln t. So if f of t is ln t, then f of x is equal to ln x. So let's replace this with f of t. So g prime of x is the derivative of the integral of f of t dt. And this entire expression, the derivative of the antiderivative of f is going to be f, but we just got to replace t with x. So this is equal to f of x, which is equal to ln x. Now this is the final answer. Try this problem. What is the derivative with respect to x of the integral of 3x, let's say cosine t squared dt? So the final answer, all you need to do is replace t with x. It's going to be cosine x squared. Now what if we have something else other than x? So what if it was like, let's say this is 1 to 3x square root 1 plus t squared dt. What should we do in this case? Well, the final answer is going to be the square root of 1 plus, now you need to replace t with 3x, so 1 plus 3x squared, and then all you need to do at this point is multiply by the derivative of 3x times 3. If you do it this way, you're going to get the answer, but I'm going to explain why it works later in this video. Perhaps I should explain it now before I forget. So g of x is equal to the antiderivative of 1 to 3x square root 1 plus t squared dt. So let's keep in mind that f of t is the square root of 1 plus t squared. So let's differentiate both sides with respect to x. So g prime of x is the derivative of the integral of f of t dt. And we know that g prime of x is going to be f of x. But really and truly, this should be g prime of 3x, since this is no longer x. So we should probably fix this expression. So this is going to be g of 3x. So looking for g prime of 3x. So g prime of 3x is f of 3x times the derivative of the inside, which is 3. And since f of t is the square root of 1 plus t squared, f of 3x is going to be 1 plus 3x squared times 3. And so this is the final answer. Here's another example for you. What is the derivative with respect to x of 3 to the 5x t cubed sine t dt? So the first thing you need to do is replace t with 5x. So it's going to be 5x to the third power sine 5x. And then multiply this expression by the derivative of 5x, which is simply 5. Now what about this one? What is the derivative with respect to x? 0 to x cubed t to the 4 dt. So first replace t with x cubed. This is going to be x to the third power raised to the fourth, and then multiply it by the derivative of x cubed, which is 3x squared. So x to the third raised to the fourth power, you need to multiply the exponents. This is 12, 3 times 4 is 12, times 3x squared, which is 3x to the 14. So this is the final answer. Now what about this one? Let's say if x is the lower limit instead of the upper limit. What would you do for this problem? So we still need to plug in x. We need to replace t with x. So it's going to be x squared, but because it comes at the bottom, we need to put a negative in front of it. It's going to be negative x squared instead of positive x squared. Likewise, let's say if you have the derivative of x squared to 7 And let's say this is ln dt. This is going to be negative ln x squared, and then multiply it by the derivative of x squared, which is 2x. So the final answer for this example is negative 2x ln x squared. Now I'm going to show you another way to find the answer to these problems, but a more systematic approach. But before I go over that, we need to talk about the fundamental theorem of calculus part 2. So let's do some examples on that first. Now I'm going to use capital F of x to represent the antiderivative of lowercase f of x instead of g of x. So let's say capital F is the antiderivative of f. That means that the derivative of capital F is lowercase f. Now, according to the fundamental theorem of calculus part 2, if lowercase f is continuous on the closed interval a to b, then the antiderivative from a to b of f of x dx is simply f of b minus f of a. So let me show you how to apply this in a problem. Let's say if we want to find the integral from 1 to 3 x squared dx. You need to find the antiderivative of x squared. To do that, add 1 to the exponent, so 2 plus 1, and then divide it by that result, 3. And let's evaluate it from 1 to 3. So this is going to be f of 3 minus f of 1. So this is the antiderivative of x squared, which is basically capital F. So capital F is x cubed divided by 3. So let's plug in 3. So it's going to be 3 to the third power divided by 3 minus 1 to the third power divided by 3. 3 to the third is 27. So we have 27 over 3 minus 1 over 3. So the final answer is 26 over 3. Let's try some more examples. Go ahead and evaluate the integral from negative 3 to 4, 7 dx. So the antiderivative of 7 is 7x because the derivative of 7x is 7. And let's evaluate it from negative 3 to 4. So we're looking for f of 4 minus f of negative 3. And f of x is 7x. So this is going to be 7 times 4 minus 7 times negative 3. 7 times 4 is 28. 7 times negative 3 is negative 21. Since we have two negative signs, we could turn the subtraction into addition. So it's 28 plus 21, which is equal to 49. Let's try another example. Try this one. Go ahead and find the antiderivative from 3 to 8 for the function 5x minus 2 dx. So the antiderivative of 5x is 5x to the second power divided by 2. So make sure you add 1 to the exponent. The antiderivative of a constant, simply add x to it. So now let's find f of 8 minus f of 3. So f of x is 5x squared over 2 minus 2x. So let's plug in 8 into the function. So it's 5 times 8 squared divided by 2 minus 2 times 8. So that's f of 8. And then minus f of 3, which is 5 times 3 squared over 2 minus 2 times 3. 8 squared is 64, and half of 64 is 32. So we have 5 times 32. 2 times 8 is 16. 3 squared is 9. 9 times 5 is 45. And half of 45 is 22.5 minus 6. What's 5 times 32? 5 times 30 is 150. 2 times 5 is 10. So it's 160. So we have 160 minus 16 minus 22.5 plus 6. Negative 16 plus 6 is negative 10. And 160 plus negative 10 is 150. Now 22.5, you can view it as 20 and 2.5. 150 minus 20 is 130, and 130 minus 2.5 is 127.5. So this is the final answer. Alright, try this one. What is the antiderivative from 1 to 32 x to the 3 over 5 dx? So we need to add 1 to the exponent. So 3 over 5 plus 1 is basically 3 over 5 plus 5 over 5, which is 8 over 5. So this is x raised to the 8 over 5. Now instead of dividing it by 8 over 5, we can multiply it by 5 over 8. And this is going to be evaluated from 1 to 32. So this is equal to f of 32 minus f of 1. So that's going to be 5 over 8 times 32 raised to the 8 over 5 minus 5 over 8 times 1 raised to the 8 over 5. So what is 32 raised to the 5/8? So let's do that separately. So 32 raised to the 8 over 5 is the same as 32 raised to the 1/5 raised to the 8 power. You can separate the 8 and the 1/5. The fifth root of 32, what is that? What times what times what times what times what? 5 times is 32. The fifth root of 32 is 2, because if you multiply 2 5 times, you get 32. And now what is 2 to the 8th power? Well, 2 to the 8 is basically 2 to the 4th times 2 to the 4th, since 4 plus 4 is 8. And 2 times 2 times 2 times 2, 4 times is 16. So this is 16 times 16, which is 256. So what we now have is 5 over 8 times 256 minus 5 over 8. 1 raised to anything is simply 1. Now what is 256 divided by 5? Well, we said 256 is basically 16 times 16. And I'm going to convert one of the 16s into 8 times 2. So I can cancel the 8s. Now 5 times 2 is 10. 10 times 16 is 160. So it's 160 minus 5 over 8. Now let's combine those two into a single fraction. So what is 160 minus 5 over 8? Let's multiply 160 by 8 over 8. 100 times 8 is 800. 60 times 8 is 480. So if we add these two, we should get 1280. So this is 1280 divided by 8 minus 5 over 8. So the final answer is 1275 divided by 8. Let's try another example. What is the antiderivative from 1 to 2 of 5 divided by t to the 4th dt? Now before we could find the antiderivative, it's wise to rewrite it. Let's move the t variable to the top. So it's going to be 5t to the negative 4 dt. So now let's find the antiderivative. Let's add 1 to the exponent. Negative 4 plus 1 is negative 3. And then let's divide by negative 3. So this is equal to f of 2 minus f of 1. So f of t, if we rewrite it, it's going to be negative 5 over 3 to t to the 3rd power. We need to bring the t back to the bottom so that we can have a positive exponent. So this entire expression is equal to negative 5 over 3 times 2 to the 3rd power minus negative 5, 3 times 1 to the 3rd power. Two to the 3rd power is 8. And this is going to be plus 5. 1 to the third is 1 times 3. So what we now have is negative 5 over 24 plus 5 over 3. So let's get common denominators. Let's multiply this fraction by 8 over 8. So now this is negative 5 over 24 plus 40 over 24. And 40 minus 5 is 35. So the final answer should be 35 divided by 24. Let's try this one. What is the the antiderivative of 1 to 4 square root x dx? So feel free to pause the video and work on that example. So let's rewrite it as x to the 1/2. So we need to add 1 to 1/2. 1/2 plus 1 is the same as 1/2 plus 2 over 2, which is 3 over 2. So this is going to be equal to x raised to the 3 over 2. And instead of dividing it by 3 over 2, let's multiply it by 2 over 3. So this is equal to f of 4 minus f of 1. Now f of 4 is 2 over 3 times 4 raised to the 3 over 2 minus f of 1, which is 2 over 3 times 1 raised to the 3 over 2. So we have 2/3 times 4 to the 3/2, which is basically 4 raised to the 1/2 raised to the third. And 1 to the 3/2 is basically 1. Now 4 to the 1/2 is the square root of 4, which is 2. And 2 to the third is 8. So we have 2 over 3 times 8 minus 2 over 3 times 1. Well, we can factor 2 over 3. And then we're going to have 8 minus 1, which is 7. So this is equal to 2 over 3 times 7, which is 14 over 3. So that's the final answer. Let's try another problem. Let's calculate the integral of cosine theta d theta from pi over 6 to pi over 3. So go ahead and try this one. So what is the antiderivative of cosine theta? The antiderivative of cosine is sine theta, since the derivative of sine theta is cosine theta. And let's evaluate it from pi over 6 to pi over 3. So this is going to be equal to f of pi over 3 minus f of pi over 6. And that's equal to sine pi over 3 minus sine pi over 6. Pi over 3 is 60 degrees. Pi over 6 is 30. If you don't remember what sine 30 and sine 60 is equal to, you can draw the reference triangle, particularly the 30, 60, 90 triangle. Across the 30 is 1. Across the 60, root 3. Across 90 is 2. So according to SOHCAHTOA, sine 60 is equal to the opposite side divided by the hypotenuse. So therefore, sine 60 is root 3 divided by 2. Now, sine 30 is equal to opposite, which is 1, divided by the hypotenuse, which is across the box, so the 90-degree angle. And sine 30 is 1/2. So this is equal to the square root of 3 over 2 minus 1 over 2, which is simply root 3 minus 1 divided by 2. That's it for this problem. Try this one. What is the antiderivative of secant squared from 0 to pi over 4? The derivative of what trig function is secant squared? The derivative of tangent is secant squared, so the antiderivative of secant squared is tangent. So this is going to be equal to f of pi over 4 minus f of 0. So this is tangent pi over 4 minus tangent 0. Tangent pi over 4, or tangent 45 degrees, is equal to 1. Tangent 0 is 0, so the final answer is 1. Let's try one more example using part 2 of the fundamental theorem of calculus. Try this one. Find the antiderivative from 1 to 2, 5x times 2x minus x cubed dx. So for this problem, you don't want to integrate it the way it is. You want to distribute the 5x to the 2x minus x cubed. So that's going to be 5x times 2x is equal to 10x squared, and 5x times x cubed, that's 5x to the 4th power dx. So now let's find the antiderivative. The antiderivative of 10x squared is 10x cubed divided by 3, and for x to the 4th, it's going to be x to the 5th divided by 5, evaluated from 1 to 2. And this is equal to f of 2 minus f of 1. Now f of x, if we simplify, it's going to be 10 over 3 x cubed minus x to the 5th power. So the definite integral is equal to f of 2, which is 10 over 3, times 2 to the 3rd power, minus 2 to the 5th power, and then minus f of 1, which is 10 over 3, times 1 to the 3rd power, minus 1 to the 5th power. 2 to the 3rd power is 2 times 2 times 2, which is 8. 2 to the 5th power, if you take 5 2's and multiply them together, you should get 32. And this is going to be minus 10 over 3 minus 1. So 10 times 8 is 80. So we have 80 over 3 minus 32 minus 10 over 3 plus 1. 80 minus 10 is 70. Negative 32 plus 1 is negative 31. So now we need to get common denominators. Let's multiply 31 by 3 over 3. So what's 31 times 3? 30 times 3 is 90, and 1 times 3 is 3, so this is going to be 93. And 70 minus 93 is negative 23. So this is it. Now let's go back to the questions that we were solving in the beginning. This time we're going to combine parts 1 and 2 to answer it. So let's say if we wish to find the derivative of the integral of 1 to x t squared dt. Now if you know how to integrate t squared, this is simply going to be t to the 3rd divided by 3. But sometimes you may get a function in which you don't know how to integrate it. But let's say since we could, we know it's going to be this. And we still have the ddx symbol in front of it. This is evaluated from 1 to x. So we know this is going to be x cubed divided by 3 minus 1 over 3. The derivative of x cubed over 3 is 3x squared. And the derivative of a constant is 0. So we just get x squared since the 3's cancel. But now, is there a general way in which we can get that same answer without having to integrate t squared? And it turns out that there is. So the antiderivative, or rather, t squared is simply f of t. Let's replace that first. Now we know that the antiderivative of f of t dt is equal to capital F. So therefore, the integration of lowercase f is capital F of t, evaluated from 1 to x. And this is equal to f of b minus f of a, or f of x minus f of 1. Now the derivative of capital F is lowercase f. And f of 1 is a constant. The derivative of a constant is 0. So this is simply f of x. Now, if f of t is t squared, so this is f of t, f of x is going to be x squared. And that's the answer. So notice that we didn't have to integrate t squared, because sometimes you're going to get a function in which it's very difficult to integrate. Let's try another example. Try this one. Find the derivative of the integral of 2x squared times t to the third dt. So if you want to do it the fast way, replace t with x squared. So it's going to be x squared raised to the third power, and then multiply by the derivative of x squared, which is 2x. So this is going to be x to the 6 times 2x, which is 2x to the 7. So that's the fast way to get the answer. But now let's show our work. So let's begin by replacing t to the third with f of t. So this is f of t dt. The antiderivative of lowercase f is capital F. So this is capital F of t evaluated from 2 to x squared. Now this is equal to the derivative. Sometimes you can skip this step. You can go straight to this part. This is equal to the derivative of f, or capital F of x squared, minus capital F of 2. The derivative of capital F is lowercase f of x squared, and you need to differentiate the nested function on the inside according to the chain rule. So the derivative of x squared is 2x. Now f of 2 is a constant. The derivative of any constant is 0. F of t is t to the third, so therefore f of x would be x to the third. But f of x squared is x squared to the third. So at this point, replace t with x squared rather. So it's x squared cubed times 2x. Let's multiply 2 and 3, that's 6. So x to the 6 times 2x is 2x to the 7. So that's the final answer. And notice we didn't need to integrate t to the third. So it really doesn't matter what the function is. We can always get the right answer. Let's try this one. The derivative of the integral of x cubed, or from x cubed to 4, of 4 plus t squared dt. What is the answer for this expression? So go ahead and try this one. See if you can get the answer. Let's begin by replacing, well, let's do it the fast way first. So we need to replace t with x cubed. So it's going to be 4 plus x cubed squared. Now, because it's the lower limit and not the upper limit, let's add a negative sign. And then let's multiply it by the derivative of x cubed, which is 3x squared. So we should expect that the final answer should be negative 3x squared square root 4 plus x to the 6th power. But now let's justify it. So let's begin by replacing the square root of 4 plus t squared with f of t. The antiderivative of lowercase f is capital F, but evaluated from a to b. So this is going to be f of b minus f of a. So b is 4, and a is x cubed. So it's f of 4 minus f of x cubed. F of 4 is a constant, so the derivative of a constant will be 0, minus the derivative of capital F is lowercase f, and then we need to differentiate the inside function. The derivative of x cubed is 3x squared. So it's going to be negative 3x squared. And now let's replace x cubed, let's replace t with x cubed. So let's plug in x cubed into this equation. So this is the square root of 4 plus x cubed squared, which is negative 3x squared square root 4 plus x to the 6th power. So this is the answer. Try this one. So how can we do this the fast way? And also, how can we justify our answer? To do it the fast way, it's going to be natural log of the top part, or of b. So replace t with 3x squared, and then multiply by the derivative of 3x squared, which is 6x, and then minus the part on the bottom. So replace t with 2x, so it's going to be ln 2x times the derivative of 2x, which is simply 2. So that's the answer for this problem. But now let's show why that's the case. So let's begin by replacing ln t with f of t. The antiderivative of lowercase f is capital F, evaluated from a to b. And that's going to be the derivative of f of b, or f of 3x squared, minus f of a, or f of 2x. The derivative of capital F is lowercase f, and on the inside we have 3x squared times the derivative of the inside part of the function, which is 6x, minus f of 2x times the derivative of the inside part, which is 2. To find f of 3x squared, we need to replace t with x. So instead of ln t, since f of t is ln t, f of 3x squared is going to be ln 3x squared. So it's that times 6x minus ln 2x times 2. So this is the answer. For the sake of practice, try this one. So to get the answer the fast way, it's going to be, let's plug in the top part of the function, x cubed. So it's 1 over square root 3 plus x cubed squared, and then times the derivative of x cubed, which is 3x squared, and then minus. Now let's plug in the bottom part of the function. So it's 1 divided by square root 3 plus x squared squared times the derivative of x squared, which is 2x. So this is going to be 3x squared over square root 3 plus x to the 6th power minus 2x over square root 3 plus x to the 4th power. So now let's get the same answer shown work. So let's begin by replacing the function with f of t. The antiderivative of f of t is capital F of t, evaluated from a to b. So this is going to be f of x cubed minus f of x squared. So let's move this to the top, and let's continue. The derivative of capital F is lowercase f of x cubed times the derivative of x cubed, which is 3x squared, minus lowercase f of x squared times the derivative of x squared, which is 2x. Now remember, f of t is equal to 1 divided by square root 3 plus t squared. So f of x cubed is 1 divided by 3 square root 3 plus x cubed squared times 3x squared minus f of x squared, which is 1 plus square root 3 plus x squared squared times 2x. So now we have 3x squared divided by square root 3 plus x to the 6th power minus 2x divided by square root 3 plus x to the 4th power. So now you know how to find or how to answer the questions that we've talked about in this video. So you can do it the easy, fast way, or you can just use the process that we outlined to get the same answer. So that is it for this video. Thanks for watching and have a great day.